Today, we are moving into using the derivative and using the stuff that we have learned about maximum minimums in context. So we're going to see some actual applications here. And in order to start that, we're going to learn something called marginal analysis. All right, so marginal analysis is kind of an economics application of derivatives. And we are going to start by learning some formulas. So we have three things that we're going to care about right now. The first is our revenue function. And our revenue function, we typically write R of X, where X is the number of units. And revenue is the price function. Actually, I'm going to write it this way, is equal to the price function times the number of units. So revenue is equal to price times number of units. Now the price function, the price function that we have right here is also known as the demand function. So I can also think of it as demand times number of units. We also have a cost function that we're going to be thinking about. And our cost function is big C of X. And we say that it is equal to C bar times X, where C bar is average cost. So cost is equal to average cost times number of units. So this is price or demand. This is average cost. And what average cost it is, just to make sure that you guys understand fully, average cost is like saying, if I make 1,000 units, it might cost me $2 million to create 1,000 units. Now, that doesn't mean that it cost me the same amount to make every single unit, right? So maybe it cost me $1 to make the first unit, and then, no, maybe it cost me $10 to make the first unit because I had to get everything set up, and then it cost me $10 to make the second unit. But once I started making more things, the amount that it cost me to increase would go down. So maybe the first two cost $10, and then it cost $9, and then it cost $7 to make the fourth one, and then $5 to make the fifth one. Average cost is the amount that it costs to produce one unit, assuming that it costs the exact same thing to make all of them. So like, if it cost me $100 to make 10 units, then average cost would be $10 per unit. Okay, so we have our revenue function, we have our cost function, and our last function here that we care about is our profit function. And I want you guys to be careful because we use a P for price or demand, but we also use a P to represent profit. So profit is a big P, whereas price or demand is a little p. So just be careful about the difference between those two things. And my profit function is equal to my revenue function minus my cost function. So be careful, our big P is profit, and our little p is price or demand. Okay, so these three functions, you need to know these three formulas, so you should just memorize them, although hopefully they're pretty logical for you guys. So marginal functions are the derivatives of these economics functions or of these business functions. So marginal revenue would be R prime of X. And marginal cost would be C prime of X. And marginal profit would be big P prime of X. Marginal. What does the derivative represent again? What does the derivative tell me about a function? It tells me the slope. Good job. The slope of the tangent line. And the slope, remember, is the change in y over change in x. So the slope is the rate of change. So in other words, a derivative is telling me the slope of a function. It's telling me how fast that function is changing. So what that means about these marginal functions is what they're telling me is how much revenue would change, how much cost would change, how much profit would change if we increase the number of units just by one. So they tell me how much revenue or cost or profit would change if the number of units is increased by just one. 0? Emil, I don't know what you're asking. Okay, all right then. So we're going to have p of x is equal to negative 3x squared plus 600x represent the price function. What should we sell, guys? We should sell something interesting. What are we going to sell? What's this the price function for? Masks. We could sell masks. What else could we sell? Popcorn. Kids. Oh my gosh, Emil, what? I mean, wait, hang on. What's the price going to be? It's up there. Should we sell children? I don't know if that's appropriate for us to sell children. Okay. I don't know if I feel okay about this. We can't sell unicorns. I mean, that's just as bad as selling children, right? Like if we sell unicorns, they're like majestic, beautiful creatures that are like out there on their own. Kangaroos. Clown. Let's sell clown cars. Okay, I feel like that's an appropriate thing to sell. Okay. A company selling clown cars. Sorry, guys, I don't want to sell animals. I just feel so bad about that. And kids, I mean, I guess are kind of animals. I feel like maybe I should know what that is, Mikhail, but I don't. Okay, so we're going to do a few things, but we're going to do them piece by piece. So the first thing that we want to do, the first thing that we're going to be asked about is to find, oh. So we're going to find the marginal revenue when x is equal to 300 units. Okay, so in order to do this, I was given my price function, not my revenue function. So the first thing that I need to do, my first step of this type of problem is I'm asked for marginal revenue, so I need to find revenue. Before I can even think about marginal revenue, I need to find revenue. So here we're going to find revenue before finding marginal revenue. Okay, so this is where we're going to use that formula that we started off today with. Revenue was equal to price times the number of units. So here, my revenue function is going to be equal to negative 3x squared plus 600x times x, where we're just using our formula, r was equal to p times x. So then this is negative 3x cubed plus 600x squared. Then we're going to take the derivative to find marginal revenue. And in this case, our derivative is pretty straightforward because it's just some power rules. So I have negative 9x squared plus 1200x. So that is my marginal revenue function. Okay, now only after we have found the marginal function, we plug in the value in question. So now I'm going to be looking at R prime of not 3, but 300. And so when I plug this in, I'm going to have negative 9 times 300 squared plus 1200 times 300, which gives me 300 times negative 2700 plus 1200. Negative 450,000. So marginal revenue is money, so I'm going to put a dollar sign in front, and this right here is my marginal revenue at X is equal to 300. Canada, you guys put it after, actually. I can't remember. I always write it in front, but I don't think it matters. Okay, are there any questions about what we just did here? Okay, so then our next part, our part B, is going to be to interpret this result. Okay, so if I want to interpret this result, that's going back up to this star that we had right here. The marginal functions are telling me, in this case revenue, how much revenue would change if the number of units is increased by just 1. So marginal revenue at 300 is negative 450,000. So what this result means is that if production increases from 300 to 301 units, revenue itself, not marginal revenue, but revenue itself will decrease, because it's minus, will decrease by 450,000. Yes, these clown cars are mega expensive. Okay, I think if we plug in 300, hang on, I think I actually did it somewhere. To the revenue function, no, I did that. No, I didn't. Oh well, doesn't matter. Okay, so next, our question 2, we're gonna call this, actually, I'm gonna go up here and put this as a 1, because this is gonna be like a multi-part example. So here we're gonna have this as 1. And for question 2, we're gonna say, given average cost for the same clown car company, find, how did I do right up here? We're going to find find marginal cost at x equals 50. Okay, so we're gonna follow our same steps here. Our step 1 is, I was given marginal cost, but I'm asked if, I was given average cost, but I'm asked to find marginal cost. So I need to start off by finding the cost function. And I know that the cost function is equal to average cost times the number of units. That was the second formula that we saw earlier today. So that means that C is equal to 357x plus 1800 times x. Which is 357x squared plus 1800x. So then we can take the derivative of this to find marginal cost. So this is our cost function. So then C prime of x, my derivative, will be 714x plus 1800, and that is marginal cost. And then I'm asked to find this at 50. So now that I have marginal cost, I can plug in the 50. So I'm looking at C prime of 50 to get 714 times 50 plus 1800 is equal to 37,500, which is money. Okay, so that is my answer. And now we're going to be asked to interpret the result. So what does this result mean if we base it on how we said the last one? You got it. So making one more unit from 50 to 51 would increase cost by 37,500. So production increases from 50 to 51 units. So I want to be clear. This is not saying if we just increase by 1 unit anywhere. It's saying if we increase by 1 unit from where we are. So if I just say if we increase by 1 unit, that's not correct. If I increase from 50 to 51 units. If I increase from 53 to 54, then my marginal cost will be different. So it's specifically if production increases from 50 to 51 units. And in this case, it's increase because the value was positive. So cost will increase by $37,500. Okay, are there any questions so far? Okay, so now I'm going to add one question to this that we didn't ask before, which is what happens to the cost in the long run? What does in the long run mean? It means long term. It means long term. In other words, exactly, it means increases. It means as I sell more and more and more units. So in the long run, this is like saying as X approaches infinity, if I let the number of units get really, really, really big. So this right here, if you're asked about what happens in the long run, then to do that, you evaluate the limit as, not in, sorry, as X approaches infinity of the cost function. And my cost function was 357 X squared plus 1800 X. And what happens when I plug in infinity to this thing? Just infinity. So what does that mean in terms of cost, etc.? That means that as I sell more and more units, cost will just keep getting higher and higher and higher. It will keep increasing. And it's just going to keep getting more and more expensive to make these cars. Okay, are there any questions about that? We are now arriving at part 3 of our multi-part problem. Accept that. There we go. Okay, so the next part is the clown company. We're just going to remind ourselves of the revenue and cost function. The clown car company had revenue It's not showing up, is it? Can you guys see what I'm writing? No, okay, hang on. Two seconds, guys. I feel like I've got to do something about whatever's happening with this iPad. Maybe I just need a new iPad that's just not connecting. Are you kidding me? Okay. Wait, I might have a solution. Give me a second. It's not the best solution if this isn't going to work. Let's see. Give me a second. I feel like it had been working so well, and now it's just like, nope. Good. Y'all ready? The clown car, we're just going to remind ourselves that the clown car had revenue function. The clown car company had revenue function. R of x was equal to negative 3x cubed plus 600x squared. And cost function, C of x was equal to 357x squared plus 1800x. Okay. So our first thing that we're going to do for this part 3 is find marginal profit at x equals 10 units. And we know that the first thing that we want to do in order to find marginal profit is to actually find the profit function. So remember that our profit function was equal to the revenue function minus the cost function. You got it. Good job, Marino. So we're going to calculate profit. So profit is equal to my revenue function minus my cost function. Did I do that right? Brackets. You guys are getting good at this. Brackets. I'm subtracting the whole thing. That minus sign gets distributed to the inside. So I end up with my profit function is equal to minus 3x cubed plus 600x squared minus 357x squared, then minus 1800x. So this is my profit function. And then I want to take the derivative of my profit function to find marginal profit. And so this is marginal profit. And then lastly, I plug in the value in question. So P prime of 10 in this case. So that's negative 900 minus 1800, negative 2700 plus 4860 gives me 2160. And that is my marginal profit when X is equal to 10. Okay, are there any questions about what we have done to find that marginal profit at 10? And if not, you should be thinking about what this result means. Tell me in the chat. Let's interpret the result together. What does that 2,160 mean? No. So okay, we're getting closer. So this is not the profit. This is not telling me that if I sell 10 units, I'm going to make $2,160. It's the marginal profit. So what is marginal profit telling me? You got it, Gwen, exactly. So it's not even just saying if I make one more unit, profit will increase by 2,160. It's saying specifically if production increases from 10 clown cars to 11 clown cars, profit will increase by $2,160. Let me double check. I did it in my head, so it could be wrong. It's 2,160. It's 2,160. Okay, so just to make sure that this is really like stuck in your heads, let's kind of think about this. So let's do profit at 10 units. That would be P of 10. So my profit function is -3 times 10 cubed plus 243 times 10 squared minus 1,800 times 10. And that gives me 3,300. Okay, yes, exactly. Would it be 0? Would what be 0? I'm confused about your question, Marino. Yes, Mikhail, this will be on the final. Yes, Marino, you got it. Okay, so this right here, this 3,300 is saying that if I sell 10 units, I'm gonna make $3,300. That marginal profit is saying if I go up to 11, I'm going to increase my profit by $2,160 from where I am. So here this is saying selling 10 cars gets a profit of 3,300. Increasing production by 1 unit should increase profit by 2,160 to a profit of 5,760. Okay, does that make sense? Okay, so are there any questions about this stuff? And by 5,760, I can do math. I mean 4 here. Okay, so we are going to actually have a part 4 of this question, but it's going to be in the next section of things called optimization. And optimization is really what we're going to work on next class. So we're going to be doing optimization. And our question 4 is going to be, it is for you, to be, how many cars should be sold to maximize profit? At what price? What will the maximum profit be? Okay. Where do maxima occur? So we've been doing this with curve sketching, and then we had a whole bunch of tests before that, and we learned like how to find maximum on curves. Where do maxima occur? When we change from increasing to decreasing, and where do those changes happen? What's the name of the places where they happen? Critical values, good job. So maxima occur at critical values. So the thing that we're going to start off doing here is finding our critical values. So the first thing we want to do though, before we find critical values, is we want to have the function that we're looking at. So our first step that we're going to do here, and I'm going to post the steps for optimization online, but our first step is to write down an equation for the function that you are trying to optimize. So in this case, that's my profit function. I already found my profit function, but we saw that I actually had to do some work to find it. Like this actually was a big three-part question that built me up to being able to find my profit function. First, I found revenue, then I found cost, then I subtracted revenue and cost and got my profit function, which was that negative 3x cubed stuff. So my profit function here is negative 3x cubed plus 243x squared minus 1800x. Now my next step is a step that's not going to matter here, but I'm going to write it down so that we have them in your notes. But like I said, I'm going to post a document between now and the next class that has all those steps, and you should like glue that document in your notes or something. So the next step is, if the function is in more than one variable, rewrite it in terms of one variable. And that's not applicable to this problem because my profit function is in terms of just one variable. Not applicable. So then I go on to my third step, which is to find the critical values. So because we just said that maxima occur at critical values, I know that I need to find those critical values. So I want to find f prime of x and use it to find the critical values. So here, my profit function is what I want my derivative of. So I'm trying to find marginal profit. So I already did that. I have negative 9x squared plus 486x minus 1800. That's my marginal profit function. So I'm going to set p prime equal to 0. So this right here, to set equal to 0, I'm going to need to factor it. And I'm going to start off by factoring out that negative 9 because that's the greatest common factor. And now I want two numbers. I want them to multiply to give me 200, and I want them to add to give me negative 54. And those two numbers are going to be 50 and 4. You are also welcome to use the quadratic formula here. So this is negative 9 times x minus 50 times x minus 4 is equal to 0. So we're just going to make a note here that you could also use the quadratic formula. And the values that we get here are x equals to 50 and x is equal to 4. Then we want where p prime does not exist. Does that ever happen? Never. So we'll just write never here. These critical values are representing number of units. So 50 and 4 are both valid things for number of units. So that said, sometimes you'll get critical values. If I got a negative critical value here, I clearly can't sell a negative number of cars. So we need to get rid of any critical values that don't make sense in the context of the problem. Gwen, that's what I'm saying. I have a document that has all of the steps summarized on it that I'm going to post on Leia like right after class or by the end of the day today. And so then you'll have all of those steps like nice and summarized for you in a clear place. Okay, so then my next step is, so I know that that 50, that 4, they could potentially be maximums or minimums. So maybe one of those is my maxima. So what we're gonna do next is we've learned 3 tests for determining if things are max or mins. So typically the easiest test to apply in this situation is the second derivative test. So we're going to say apply the second derivative test to determine if your critical values are max or min. Okay, so my second derivative test, I need p double prime of x. So I end up with negative 18x plus 486. And so now I'm plugging my values in here. So into p double prime, I'm going to plug in 50. And I'm plugging in 4. And when I plug in 50, I get a negative value. And when I plug in 4, I get a positive value. If I get a negative value for my second derivative, is that concave up or concave down? Is concave down. So is the 50 a max or a min? You got it. And if it's concave, if it's greater than 0, that's concave up, so that's a min. So in that way, I've eliminated the possibility that 4 is my maximum profit. My maximum profit is going to come from 50. So here we can say x equals 50 maximizes profit. And then my final step is to answer the question asked. So answer any given questions. So in this particular example, we were asked how many cars should be sold to maximize profit, at what price, and what will maximum profit be? So we are saying how many cars, at what price, what is max profit? So how many cars, we already answered that. X equals 50 cars should be sold. At what price? Do I have my price function? If we go back, remember, this is the same problem that we've been doing all class. I've literally done one problem this class. So if we go back, my price function was actually the very first thing that we were given. Negative 3x squared plus 600x. So price, remember, is also revenue equals to price times number of units. So I could also get it from my revenue function. But here I have my price function, so I'm going to plug into that. Negative 3x squared plus 600x. So here we remember that P of x is equal to negative 3x squared plus 600x, and that is from the first part. So now I'm doing price at 50 units is negative 3 times 50 squared plus 600 times 50. So 22,500. So now we're seeing that these clown cars, if we're maximizing profit, actually cost $22,500, which is actually maybe a reasonable price for a car, although maybe not for a clown car. Okay, now, so I plugged into my price function to get that. And then my maximum profit, I'm plugging that 50 in to my profit function. So that's negative 3 times 50 cubed plus 243 times 50 squared minus 1,800 times 50, which gives me 142,500. So my final answer is 50 clown cars should be sold at $22,500 per car for a maximum profit of 142,500. And that is the final answer. And next class, we're going to spend the whole class working on optimization. We're going to see a couple other types of optimization questions. And like I said, I'm going to post this summary of all of the optimization steps. So you should definitely print that out, write it in your notes, do something so that you have it in a nice, like summarized space, and you have it in a good, easy space for you to find it. Are there any questions about this though? If not, we are done.